Hello everyone, this is Aslam Shareef, Assistant Professor in Physics Department, Laws Institute of Engineering and Technology. Today we are going to discuss some basic concept and the concept related to laser in series of laser chapters. Let's see what is there in the next. First, we'll go with the learning objective and outcome. So here we are going to cover understanding the basic principle of lasers, explain stimulated emission and population inversion. Also, we'll be seeing Einstein A and B coefficient. And with respect to this, the Bloom taxonomy, what we are going to cover will be BTL2 and BTL3 respectively. Let's move ahead and see what all the prerequisite for this chapter. So we need to know the basic knowledge of atomic physics to know about atoms and electrons. We need to have basic knowledge of quantum mechanics to know about photons absorption, etc. And we also need to know basic knowledge of electromagnetic theory to know light as working as electromagnetic wave. Let's go ahead with the introduction part. So the word laser is an acronym that stands for light amplification by stimulated emission of radiation. So here the meaning we are saying the light amplification. So a weak signal is becoming a strong signal. So with reference to light, we are saying a weak light is becoming a strong light. So that we are addressing as light amplification. And how the phenomena is happening, it's due to the stimulated emission. The phenomena behind laser to work, it is a principle that is called stimulated emission. So here the acronym is like light amplification by stimulated emission of radiation. So here lasers are essentially highly directional, highly intense, highly monochromatic and highly coherent optical sources. So stimulated emission was postulated by Albert Einstein as early as in 1917. In 1960, a solid-state Ruby laser is developed by T.H. Mayman on the principle of stimulated emission. In 1961, a gas laser such as helium neon laser is developed by Ali Jawan and his co-worker, and this was done in Bell Telephone Laboratory. So let's see the overview that need to be known, the characteristic of lasers. Lasers, when compared with any conventional light such as sunlight or tube light, etc., possess few outstanding characteristics. They are monochromatic in nature, basically termed as monochromaticity, and they are highly directional, so such as directionality mentioned, and they will be highly intense, also maintaining coherence. So these are the few characteristics of laser. Let's discuss them in detail. The monochromaticity is nothing but the light emitted from a laser, basically a single beam of light. A wavelength maintaining a wavelength is termed as monochromatic. So this is happening due to stimulated emission. So light emitted by a laser is more chromatic than any conventional monochromatic source such as sodium lamp. Let's go ahead with the directionality. So here light emit or laser light, basically we are saying laser emit light that is highly directional. So in order to obtain high directionality, there should be low divergence. Low divergence is nothing but having a narrow beam of light. So for a laser, the beam spread is less than 0.01 millimeter for every 1 meter. But for ordinary light, zero point 0.5 meter for every 1 meter. Next, let's see the intensity. So laser light is more intense than conventional light. So number of photons coming out from a laser per second per unit area is given by the notation n is equal to p by h nu pi r square. Now let's talk about coherence. Laser radiation has high degree of coherence. Coherence is expressed in terms of ordering of light field such as amplitude and phase. Coherence is of two types. So let's see what all the two types. So the two types are as follows: temporal coherence and spatial coherence. Temporal coherence basically is the amplitude and phase at a point on a wave which respect to another point on the same wave is said to be a temporal coherence, such as time related. Let's see the spatial coherence. So the spatial coherence is nothing but the amplitude and the phase at a wave with respect to another point on a second wave. Then the wave are said to be spatially coherence. So these are the two type of coherence: spatial coherence and temporal coherence. Let's see what next. It's atomic excitation and energy state. So let's see atomic excitation and energy state here. So when light interact with matter, three types of atomic mechanism take place in a material, and they are stimulated emission, spontaneous emission, and stimulated absorption. So these are the three types: stimulated absorption, spontaneous emission, and stimulated emission. These are nothing but the principle of laser. As you can see here, in case of absorption, we are seeing the diagram where in the ground state, all the atoms are lying in the ground state. With the external photon of energy, the atom is jumping to higher energy state by absorbing photon of energy. So this is termed as absorption. Then we are having a case where spontaneous emission is happening. So if we see the second diagram here, in the first scenario, we are taking a case where the atom is already situated at higher energy state, such as excited state. Then after spending an average lifespan or the lifetime in the excited state, the atom is coming down on ground state by emitting photon of energy on its own. Such phenomena is termed as spontaneous emission, whereas stimulated emission required a photon of energy to bring the atom back to ground state. So let's see all this principle in the coming slides. Absorption, induced absorption or stimulated absorption. So, the process in which to higher energy state such as E2 by electromagnetic radiation, which is quanta of an atom size system in lower energy state such as E1, is raised in energy, is equal to the difference of energy of the two state, is called stimulated absorption. So as we have seen, the atom which originally here in the ground state are moving to higher energy state by the external energy such as photon, called as quanta. So that is h nu energy, a photon, is being incident on the atom in the ground state. By gaining the energy, the atom is moving to higher energy state such as excited state, and the atom remains there. So this phenomena, the absorption of photon, is basically termed as stimulated absorption. Let's see spontaneous emission. In spontaneous emission, the excited atoms come back by itself on or onto the ground state. So in the process, a photon of energy such as h nu is being emitted. So if you see here in this diagram, here you can see, taking a reference from the absorption, the atom is being kept on the higher energy state. So this atom, after spending an average lifespan, is coming down to ground state by emitting photon of energy, which is the difference of two energy state. So h nu will be equal to E2 minus A1. Let's see the important features of spontaneous emission. So here it is very difficult to control the process from outside. It is essentially probabilistic in nature. The emitted photons moves at random and will not be follow any phase relations. The emitted or the light emitted in this process is incoherent and non-monochromatic. The intensity of light decreases rapidly with distance from the source. This process is proposed by Niels Bohr. Therefore, it is been termed as spontaneous emission. Let's see how the things are happening in stimulated emission. In stimulated emission, with the influence of suitable energy impetus, excited atom is triggered to the lower energy state. With the release of same energy of incident photon energy, it is termed as stimulated emission process. As we can see in the diagram below, here there is an atom from the stage 1 of absorption consideration which have already absorbed an atom and move from ground state to higher energy state. In this scenario, we are giving an additional photon of energy. We are incidenting a photon of energy to the atom which is there in higher energy state, because of which there is a stimulation process happening in the atom, and thereby the atom started moving to ground state by emitting photons of energy. As a result, we'll be getting a radiation. So if we see here, these two photon energy are maintaining zero or constant phase difference. That means they are coherent in nature. So according to Albert Einstein, under certain condition, it is possible to force an excited atom emit a photon by another photon, and the incident light wave must be in same phase. Hence, we get an exchange beam of coherent light. So important features of stimulated emission. So here the process of stimulated emission can be controlled from outside. As we are giving the photon of energy, it is being controlled from the outside. Then the emitted photon and incident photon have same direction, phase, frequency and polarization. As we can see in the previous slide, we have mentioned here the photons are in phase. Then the light procedure or the light produced during stimulated emission is perfectly coherent and monochromatic in nature. This is being proposed by Albert Einstein. Let's see the difference or the distinction between spontaneous and stimulated emission. And while we are observing the differences, we'll have observation on some key factors such as nature of emission, number of photons emitted, types of radiation, intensity and direction, nature of radiation, angular spread, and postulated by along with some suitable examples. Let's see the column of spontaneous emission. So we are saying the nature of emission is here. It take place without any stimulation of energy. Whereas in case of stimulated emission, it take place with the help of stimulus energy. Let's see the second point, which is giving a notation on number of photon emitted. In case of spontaneous emission, only single photon is emitted. As you can see in the diagram here, we are discussing the case of spontaneous emission where only single photon is being emitted. Whereas in case of stimulated emission, two photons are emitted. So if you see the diagram, here you will be able to observe that the two photons which are in phase with each other are moving from the phenomena. The types of radiation. So here in spontaneous emission, it is incoherent in nature. Therefore, it is incoherent radiation. When it comes to stimulated emission, we will see a coherent radiation. So basically incoherent, it will be random distribution or the scattering of light can be observed. Whereas in coherent, two light wave travel in the same direction maintains zero or constant phase difference. So therefore we term this as a coherent radiation. Now let's see the intensity and direction. So here in spontaneous emission, it will be having low intensity and less directional. Spontaneous emission will be less directional. As the light is getting spread across, we cannot term that as having a high directionality. Henceforth, we are giving a name here as less directional. When it comes to stimulated emission, high intensity and more directional. Since when the light is having a phase difference, they'll be having a constant phase difference means a single beam of light. When there is a single beam of light, directionality is obviously can be seen and it is possible. When it is highly directional, then the certain amount of intensity can be observed. In such scenario, we are calling this is as high intensity and more directional. Let's see the nature of radiation. In case of spontaneous emission, it is polychromatic radiation, whereas in case of stimulated emission, it is monochromatic radiation. So, example, we can take a mercury or sodium light. The light which is incidenting from them are polychromatic in nature, whereas the light which is being observed from the laser light are monochromatic in nature because of single wavelength. Angular spread. More angular spread will be observed in spontaneous emission, whereas less angular spread can be seen in stimulated emission. As you can see, this was postulated. Spontaneous emission is postulated by Niels Bohr, whereas stimulated emission is being postulated by Albert Einstein. And the examples as follows. The example for spontaneous emission is light from sodium light or a mercury vapor lamp. These are the example of spontaneous emission. When it comes to stimulated emission, we will be having a light from ruby or helium neon laser. So these are the examples of spontaneous and stimulated emission respectively. So by far we have covered the acronym of laser, that is light amplification by stimulated emission of radiation. And we have seen the characteristic such as high monochromaticity, highly directional, highly intense, and highly coherent. And we have seen the principle involved behind that, that is stimulated emission. And we also have seen the absorption, spontaneous emission, and stimulated emission phenomena. Let's see the recapitulation in terms of questionnaire. So as you can see in the questionnaire, first question, which process is responsible for laser light amplification? And options are spontaneous emission, stimulated emission, spontaneous absorption, diffraction. And the correct answer is stimulated emission. Let's see the question number 2. In a laser, coherent light means that emittent photon have options are same frequency and phase, different frequency, different phase, random direction. And the correct answer is having same frequency and phase. Let's see the third question. Which one is not a property of laser light? So here the options are coherence, monochromaticity, divergence, directionality. And the correct answer is divergence. Divergence is not a property of laser light, whereas coherence, monochromaticity, and directionality are three of the four characteristic or property of lasers. In the next series, we will be discussing about Einstein A and B coefficient. Thank you for watching. Subscribe for more videos.